This tutorial will introduce the Grasshopper environment as a tool for creative play and for exploration of geometry in ways that you couldn't necessarily do using Rhino alone. So what we're going to go through are some very simple pre-existing algorithms and modeling tools which are available within the Grasshopper environment for exploring new relationships between geometry, for exploring how we might begin to investigate differentiated geometry, and how we can capture several iterations of our parametric model by baking geometry back to the Rhino environment. So to begin with, we're just going to look at a really simple lofted example. Hopefully you've all watched some Rhino tutorials and know what a lofted surface is. It's a NURB surface that you fit through a list of curves. So as a result, if we loft these curves, you'll get a nice smooth lofted surface. Now with Rhino, if you change one of the input curves, this lofted surface won't update because there's no parametric connection between this input geometry to our loft and the output of that loft algorithm, which is the surface itself. Now in Grasshopper remembers all of this history, which is why Grasshopper used to be called explicit history. And if we change one of the inputs, our lofted surface is going to update. So let's reference these curves into Grasshopper using some parameter components. I'm going to use a curve because this type of geometry, this data type, is a curve. Set one curve. And I'm going to do the same thing for the other two components. Like so. So we have three curves stored in these three parameter components. And for convenience we can rename them if we like. I've just right clicked on this component. First, middle and end. And for now I'm also going to get rid of this lofted surface. So when we click on these curves, if you've referenced them properly, they should highlight in the Rhino display. So our first curve, our mid curve and our end curve. Now let's create a loft between these three curves using a parametric Grasshopper component. So it's in the surface menu and freeform loft. We'll connect the components up by clicking and dragging from an output to an input, holding shift to connect multiple outputs to a single input. And you'll see that Grasshopper fits a lofted surface through these curves. So that's not super duper exciting, it's exactly the same as the Rhino command that I just showed you. But if we change one of these curves in any way, so I'm pushing F10 to turn on my control points and then dragging these around, you'll see that our lofted surface updates. Now this loft also has another input, which is the loft options, and you can parametrically play around with the loft options as well by right clicking, going down to loft options and controlling what these parameters are. Now say we want to keep track of what we've been creating with this loft component so that we can capture several states of this parametric model rather than just displaying whatever this component is currently outputting. One way to do that is to bake the output of this component back into Rhino to save it in a sort of big list so we can keep track of all of the different versions or states of our parametric model. So to do that we just select the thing that we want to bake, right click somewhere on the canvas and choose bake. And you'll see that what that does is it just takes this Grasshopper model and spits it back out into Rhino. And we can drag it off our current model to keep track of it. So let's make another surface. Well, let's change this result and just bake it again. And then we can again drag this over here to keep track of it. Maybe we can try making this part a bit higher. Bake it again. Oops. Bring it back down. Make this bit higher. Etc. So now we've got a very quick way of generating multiple iterations of our parametric model. Now you might want to try plugging in more curves into this component to produce more complex surfaces. You could also try plugging in closed curves to produce a different topology. So this is a single open surface, but maybe we could make closed surfaces as well. Or you could try taking the output of this component and plugging it into some other component from these Grasshopper toolbars. So see if you can find a component which takes this data type as its input. So what takes a surface?